Today we will discuss about two-port network. In previous lecture series about network, we have discussed that how to calculate the circuit parameter like branch current, branch voltage, power of a network using several number of network theorem and network laws. Now, if I have a complex circuit, and in this complex circuit we don't need the internal circuit parameter like branch current, branch voltage, etc. But we need only the response for specific input. For this case, we take the complete complex circuit as a black box with two ports. These two terminals constitute a port and these two terminals constitute a port. This is called two-port network. Now, what is the two-port network? Two-port network is a mathematical tools. By using this two-port network, we can calculate response for specific input for a complex network without calculating the internal circuit parameter like current, voltage, power, etc. Now, there are 6 types of two-port network. One is Z parameter, number 2 is Y parameter, that means admittance parameter. This is called transmission parameter, and this is called inverse transmission parameter, and this is called hybrid parameter, and this is conductance parameter. So all these parameters are essential to study network theory. Now we will discuss one by one in the upcoming lecture series. So now we will discuss what is the Z parameter of two-port network. Impedance parameter. What is the impedance parameter? This is the suppose two-port network, and this is the entering input current, and this is the port 2. This is the entering current of port 2 is I2. This is port 1 and this is port 2, and this is the voltage of port 1 and this is the voltage of port 2. So there are 4 parameters, V1, V2 and I1 and I2. Now in this case we have to calculate the Z parameter. Okay, so V1 and V2 must be a function of I1 and I2. So in this case we can write that V1 is equals to Z11 I1 plus Z12 I2 and V2 is given by Z21 I1 plus Z22 I2. This is equation 1 and this is equation 2. Now these two equations can be shown as a matrix form. So how to show these two equations in a matrix form? You can so this is V1 and V2 is equals to the Z parameter, that means Z11, Z12, Z21, Z22, and this is I1 and this is I2. So in this matrix form you can represent these two equations. Here this matrix is called the Z open circuit impedance matrix. So this is called open circuit Z matrix or impedance matrix is called open circuit impedance matrix or Z matrix. Now we will define this four parameter, Z parameter. First of all, what is the Z11? What is the Z11? If I open circuited port 2, then I2 will be 0. So if I2 equals to 0, so when this I2 is 0, if the port 2 is open circuited, so in this case port 2 must be open circuited. So if you open circuited this port 2, then I2 becomes 0. If I2 is 0, then from this equation 1 we can write that Z11 is equals to V1 by I1 when I2 equals to 0. So how to derive this? When this port 2 is open circuited, then I2 is 0. If I2 is 0, then from this equation 1 we can write that Z11 is equals to V1 by I1. This is called input driving point impedance. This is called input driving point impedance. Now if I open circuited port 1, so number 2, when if port 1 is open circuited, so if you open circuited this port, then I1 becomes 0. Then I1 becomes 0. Now if I1 is 0, then this term will be 0. Then from equation 2 we can write that Z22 is equals to V2 by I2 when I1 equals to 0. I1 equals to 0, that means port 1 is open circuited. And this is output portion. So you can write this as output driving point impedance. This is called output driving point impedance. Now, point 3, we want to define this Z12. That means port 1 must be open circuited. So when port 1 is open circuited, then from equation 1 we can define that Z12 must be equals to V1 by I2 when I1 equals to 0. This is V1 divided by I2. So V1 divided by I2 is called reverse transfer impedance. Reverse transfer impedance. This is called reverse transfer impedance. Now, number 4, if I open circuited port 2, that means this. So if port 2 is open circuited, then I2 is 0. Then from equation 2 we can write that Z21 is given by V2 divided by I1 when I2 is equals to 0. This is called forward transfer impedance. This is called forward transfer impedance. Okay, so in this way you can define these 4 Z parameter. One is Z11, it is called input driving point impedance. This is called Z22, that means V2 by I2. This is called output driving point impedance. And this is called Z12, it is called reverse transfer impedance, that means V1 by I2. And in this case Z21, this is V2 by I1, is called forward transfer impedance. So in this case I2, this is output is open circuited. In this case the input is open circuited. Okay, so in this way you can define this Z parameter. Okay, now we will constitute the equivalent circuit of this Z parameter. Now using these two equations we can develop a equivalent circuit. So what is the equivalent circuit? Equivalent circuit. So this is V1. So this is port input input function. This is called input. This is V1. So in this case the current is I1 and there must be a impedance. Impedance is Z11. So suppose this is impedance Z11, Z11, and there must be a current control voltage source. Okay, there must be a current controlled voltage source. This is called input. So this is plus, this is minus. It must be Z12 I2. Okay, so this is the input port of this two-port network. Now if I constitute, this is port, suppose port 2, this is V2, and this is plus, this is minus, this is plus, this is minus. Now in this case this impedance must be Z, this impedance must be Z22. Okay, this is Z22, and the output entering current is I2, and this must be a current control voltage source. So here the equation, the circuit looks like this is plus, this is minus, and it will be Z21 I1. So this is the equivalent circuit of this two-port network Z parameter. Okay, this is the equivalent circuit. Now this equivalent circuit can be modified. How to modify this equivalent circuit? Now V1 can be written as, this is Z11, and this is Z12. So this is suppose Z1, and if I take, this is suppose this, I take Z12 I2. So if you take Z12 I2, so it is can be written as, this is Z11 and this is Z12. So if I write this Z11 minus Z12 into I1, then we have to write that I1 plus I2 into Z12. So from this equation we can write that Z12, this is minus portion and this is plus portion. So if I calculate this, it will become this. Okay, so this equation 1 will be this. This is suppose called equation number 3. And from this equation we can write that V2 is given by Z21 minus Z12 into I1. We have taken minus Z12 excess. Now plus Z22 minus Z12 into I2. So in this case we have taken this extra as a extra and this is extra. So you have to add this. So in this case this is I1 plus I2 into Z12. Okay, so in this way you can rewrite this equation 2, so it becomes equation 4. Now using equation 3 and 4 you can develop a equivalent circuit. So what will be the equivalent circuit of this using these two equations? Suppose this is input V1, port 1, so this is plus, this is minus. So current through this port is I1, so there must be a resistance, so this is impedance. This impedance is Z11 minus Z12, and this is another impedance Z12. So in this case this is Z12, and in this case the current in this direction must be 2. Then this is the input portion. So using this input portion we get this equation. This is V1, so V1 equals to I1 into this, and in this case the current through this portion is I1 plus I2. So it is the voltage across this point is Z12 into I1 plus I2. Now if we take this is output port 2, so this is V2, this is plus, this is minus. So in this case there must be a V2 is equals to Z11 into minus Z12 into I1. Okay, I1. So this must be a current controlled voltage source. Okay, this is called current controlled voltage source, and this is will be a, so in this portion is a current controlled voltage source, and this is simple impedance. So you take this is current controlled voltage source, this is will be plus, this is minus, this will be Z21 minus Z12 into I1, and simple this is resistance. So in this case the impedance must be Z22 minus Z12. Okay, and this is the Z12 into I1 plus I2. So this is the output port. From this port you can constitute this equation. This is V2, so V2 equals to, this is voltage source, current control voltage source, so Z12 Z21 minus Z12 into I1 plus I2 into this impedance plus this impedance into I1 plus I2. So in this way you can constitute this type of equivalent circuit. Okay, it may be this type, this is also equivalent circuit, this is also a equivalent circuit. Now you have to know what is the Z parameter for T circuit. So now you have to find what is the Z parameter for T circuit. So circuit will be T-shaped circuit. So suppose this is a Z1, this is Z2, this is Z3. So this look like a T circuit. Okay, this is the T circuit. For T circuit, you have to find out the Z parameter. So for this circuit, Z parameter 1 must be equals to Z1 plus Z3. Z22 must be equals to Z2 plus Z3, and Z12 equals to Z21 must be equals to Z3. So this is the formula to calculate the Z parameter for T circuit. Okay, so in this way